Hello and welcome to the next episode of Vieco.live. This time I'm going to talk about Git. As you might have noticed, I've changed my schedule. I'm not going to do my blogs, my live video blogs on Fridays anymore. I'm also not going to do them. I'm going to do my live blogs Mondays, 4 p.m. This new schedule, this new change, I've done it because I've realized that Friday in the middle of the day is probably the worst time to actually have a video blog. So Monday, beginning of the week, 4 p.m. Just at the end of the workday, at least here in Central European time zone where I believe most of my viewers are. So I believe this is going to work better. Of course, I'm gladly going to listen to your comments on that if you want to have a different schedule, or if you believe that a different schedule would work better, please just tell me in the comment section. So today's content is, as I said, inside Git, and I've decided to actually take a peek inside, or actually to focus myself a little bit on this Git part of development. So I would like to start with a question: why is understanding Git storage relevant? And actually, it's I'm not going to say that it's absolutely relevant that honestly, do you as a developer need to understand in detail how Git works under the hood? The answer is honestly no, you don't. But if you understand how it works on the inside, does it make you a better developer? And an answer here is a resounding yes, absolutely. So I will call back a little bit of when I started developing professionally. When I got my first job, I started developing an application, which was kind of an ERP. I didn't know it back then, but it was built on top of SQL Server. And I knew nothing about SQL Server. So I could have done some easy attempts at reading a couple of blog posts. Maybe it was 2000, year 2000, or actually 1999 to 2000. So it was difficult to find real blogs. So what I did is I decided to read a book, and I chose the book called Inside SQL Server 7 by Kellen Delaney. And that was probably the best decision I ever made about reading a book, because it was the first one where I decided to look on the inside on how things work. And that has really helped me understand how SQL Server works, and it helped me build better software. So I'm saying that because also, if you understand how Git works on the inside, you will be less scared of it. People are often scared about Git. What will happen if I do this or that? If you understand how it works on the inside, you will be far less scared about Git. Also, if you understand how it works, you will be able to approach it with more mastery. Like, you will be able to understand the consequences of your operations. You will be able to understand what happens if you do this or that. And also, you will be able to get out of difficult situations sometimes. I'm doing this series of webinars on Git. All of these webinars are paid, but I realized there is so much more to say about Git. And also, these webinars run at roughly 75 minutes per session. So there is so much you cannot put in those sessions. So I've decided to complement those webinars with this free content that I'm going to give here on my Viego.live video blog. And this is the first session I'm going to do. This is about Git storage. And yes, I believe it is relevant to understand how Git actually works. So let's start by asking the next question. How does Git track your data? And to actually show you how Git tracks data, I'm going to just start with a demo. So here I have a folder. This is the folder view of that folder. And this is a command line view of the same folder. So if I want to start with a new project, for example, I could create a new folder. I could do it from here. So I'm going to create a folder called demo, and I'm going to enter into this demo folder. So I'm now inside here. And the next thing I want to do is I want to start Visual Studio Code. And there we go. So this is my Visual Studio Code. And what I'm going to do inside here is I'm going to create a new file. I'm going to call it file1.txt, and I'm going to have content file, or actually hello world, and I'm going to save this file. And then I'm going to have another file, file2.txt, where I'll have hello Mars. Okay. So this is my two files, and this is my folder view. So if I want to start with Git in a folder, so I want this to be tracked as a Git repository. The only thing I need to do is I simply do git init, and that's actually it. Yeah. Something happened that I didn't want to happen, and I don't know why this folder is actually... I keep switching between these two settings, and it actually, as you can see, it doesn't listen to me. So I actually wanted to start here, and I did prepare this ahead of the session, and this is what I wanted to show. So this git init command, what has it actually done? It actually told you here. It says that it initialized empty Git repository in, and then it gives you this path, and this path ends with .git. This .git, as obviously you cannot see here anymore, because I have done something which I shouldn't have done. It should have worked from before the session, from my preparation, but never mind. What happened is that you have a hidden folder, and if you want to see the contents of this folder, you can either just type this .git in the address bar, or alternatively, which I do recommend if you're working with Git often, is to simply do options and then view and then show hidden folders and drives. And that should show it again, except that it doesn't for some reason on this folder here. I have to do it twice. Yeah, and now I have it. So what has happened when I did git.init is that this .git folder got created, and this Git folder has some contents inside. And I'm actually not going to explain all of these today. I'm not actually going to explain most of what is each of these. We're going to take a look at those that are relevant. But everything that Git does, everything that happens inside Git, everything that Git tracks happens inside of this folder. If you want to actually to say it with absolute precision, this is the repository. This is not the repository. So these two files, these are just files. At this stage, we could even say that these are dirty, and we will see what that means. But for now, repository is not these files. Repository, technically speaking, is this. And by doing git init, we have initialized an empty Git repository in this folder indicated in here. So that's this .git folder. So how does Git actually track your data? We have seen that when you have created this, or actually initialized a new Git repository, that you have got this new .git empty folder, which contains some files. I do not recommend that you manually edit those files. You should actually leave them alone. Or if you do something there, you should really know well what you're doing and why. But for now, let's just focus on how Git actually tracks any kinds of changes that you do. So if I take a look at my Visual Studio now, after I did git.init, I can see that these files have turned green, and then I have this small badge saying 2, which means that I have 2 files inside of my Git, or actually my source control area. And here I can see that these are changes. Normally, we would, or actually speaking strictly in Git terminology, we would say that these 2 files are dirty. What does it mean that files are dirty? Actually, I've been showing those files on screen, but you haven't seen my screen. So this is what you have after Git has initialized over a folder. And this is 2 dirty files. You can see that the files are dirty also by the presence of this asterisk next to the branch name in the status bar. So this means that this is now dirty. This branch or this repository has dirty changes. Dirty changes are those changes that have not yet been staged nor committed. So whenever you create a new file, that file will be automatically dirty. Also, every time that you initialize a new Git repository over a folder, just as I have done, all of the files in that folder will be dirty. So how does Git track my files in there? How does Git know that something has happened in my folder, because you know that when you work with your repository in Visual Studio Code, you know that you will see changes happening here. So how does Git know that? Let's actually try to address that question. The first thing to understand is that Git does not do anything automatically. That's what Visual Studio Code does for you, or other tools do for you. But Git itself does not. Git only ever does things when you tell it to do things. So if I take a look at this Git folder, if I create a file inside of my repository and I'm going to create that new file, I'm just going to call it new text document. Nothing has happened in Git. And to prove that, what I have done is I have prepared this Beyond Compare view over two folders. The left-hand side is this Git folder in here. And the right-hand side is going to be the copy of that folder. I'm just going to copy it in here. And then when I refresh this, I'm going to see, why does not it work now? Yeah, I will apparently have to do it again. I'm just going to have to select this folder. Apparently I've prepared this before my session, but now I have to do it again. So this will be my left folder, and this will be my right folder. And then when I take a look, I can see that all of these are apparently equal. I'm just going to not compare file size and not compare timestamps, or actually I'm going to leave compare timestamps. So I'm simply just going to view if anything at all changes. So I have created a file in what should be this view, and this is a copy, but I don't see it there. So also if I go in this folder and create another file, and then refresh this view, nothing will have happened. Because Git, as I said, does nothing automatically. Again, I apologize. I haven't been, I've been talking and I haven't shown my screen. I really apologize for that. So I'm just going to delete these two things from here. And then what I said is that I have this Git folder, and then I have a copy, of the same Git folder in here, and I have Beyond Compare view over them. So when I refresh this, I can see that they are both equal, they are the same. And then when I go into my demo folder, which is my repository folder, and create a new file in there, Git does not know. And when I refresh, nothing will have happened here on the left-hand side, which is my repository, because Git automatically does not track anything. If you want Git to track something, you need to tell it that it should track something. And that's what Visual Studio Code does. For you, it runs things in the background. And if I switch now to Visual Studio Code, you will see that, okay, new file has appeared here. And if I go back into my Beyond Compare view and do a refresh, I will see that something has changed. Okay, there is this fetch head, which has changed, not much more, but yeah, that's simply because the timestamp has changed, so no new content. But also, if I, for example, go back to my view and run git status, I can see that I have these uncommitted changes. And still, if I go back to my repository view, nothing much will have changed. But what will happen if I actually stage those two files? So I'm going to stage this file and this file, and then go back to my Beyond Compare view and run a comparison. I will see that a new file has appeared in my left-hand side, and this is the index file. So what is the index? Often when you're reading Git documentation, you will see that Git mentions index a lot. Also, when you get some error messages, sometimes they will tell you something about index. Often when you compare things, for example, when you take a look at this here, it will show you comparison of file1.txt and it says index. Index is essentially a file which tracks different versions of what your repository, or actually what your working directory currently holds, what your staged area actually holds at this moment, and it also knows the last snapshot of the entire Git repository, so it will know what has changed between your staged area and your committed area or repository, and what has changed between your working area and your staged area. This is the purpose of the index file. It's a binary file. It doesn't make any sense that I go into that file and show you what it contains. It contains the binary representations of essentially what I have explained. So it tracks all of the files in the staged area. It tracks all of the files, or actually it does not track. It records at the moment when you run git status. It will record the state of your staged area, and it will also record the status of your working directory. So index will update. Actually, I've just said something that is not entirely true. Index updates when you stage or unstage things and when you commit or uncommit things. There are other things that will trigger index changes, but essentially these two are the most common. So once again, when I stage or unstage files, index will update. And then when I commit or, well, I may have said uncommit, it's not also a correct thing to say. You can do things with commit. You cannot really uncommit, but you can revert a commit or stuff like that. Let's take a look at these things. So right now I have seen that my index has updated. So I can see that on the left-hand side, I have index. On the right-hand side, I do not have index. So let's actually take manual snapshot of this. I'm going to copy this Git and I'm going to replace it in here. And then I'm going to refresh this. And now I can see that these two are the same. So when I unstage these two files and then compare again, what I can see is that index has updated again. Yes, as I said, index is a binary file. Here on the left-hand side, it doesn't contain much. On the right-hand side, we can see that it does contain some data. So it means that my earlier version contained more than my new version. That's because the earlier version has contained references to two staged files. Okay, so let's take a look at more about my my index. Actually, let's take a look at what happens when I commit. So I'm going to stage this again. Actually, I will not stage this file. I do not need that file. Again, you need to understand that this is the moment where something has changed in my index. If I, for example, delete this file or revert that change, this will delete the file. It doesn't allow me to, actually it did allow me to. So this did not change the index. Only staging or unstaging has changed the index. So let's take the snapshot of this once again. I'm going to copy this Git from my repository, or actually my working directory, and I'm going to replace that inside of my temporary storage, which I use for comparison. And then I'm going to refresh again, and then we can see that everything is exactly the same. So the next thing I'm going to do is a commit. So I'm going to do initial commit. Typically, this is what you call your first commit in your repository. So when I commit, several things will have happened. If I go back to my Git and I refresh, I can see that, of course, index has changed. That's because my staged area no longer contains those files. My staged area is now empty. However, I have some committed references which need to be stored somewhere. They're not stored just in the index. You may notice that a couple of more things have changed. Okay, I've got this logs folder, which now contains some information about my references. We are not going to go into that part now. Also, I've got my refs folder. This contains the lists of my branches. So each of these files is a branch. So at the first commit, you have actually got your first branch, and it is here. So, and I've also got several objects in here. I can see that my objects folder is no longer empty. If I open that, I can see that I have some objects in there. So I have 1, 2, 3, 4, 5 objects. In short, since I have been showing you some staging, etc., things have happened on both sides of this. What I want to show you is what happens if I commit all of these files in a fresh empty repository as a first single commit. So let's take a look at that. What I'm going to do at this point is I'm going to get rid of my entire repository. How do I do that? I simply go in my my repository folder and just do delete of this .git folder. So when I'm back in my Visual Studio Code, I can now see that, okay, it is a little bit confused. So I'm going to reload my developer window. It should not be showing these things. I'm going to close it and then start it completely afresh. This is really strange. It shows me all of these things, even though it doesn't have anything about it in there. So I'm just going to go into this open with code. Let me see. I suspect that something is happening here with, so I'm going to show all of my folders. There, I've never seen this. So I'm running Visual Studio Code over here and it contains stuff. Let me try to run Insider's version of Visual Studio Code. It also sees this as a Git repository. And this is really strange because, oh, of course, yeah, I totally apologize. This is what is happening. I must not put this in here. What I'm going to do is I'm going to put a new folder called comparison. I apologize. So if I now go in here, I will see that, yes, there is no Git. This is a fresh new view over my, just a folder. This is not a repository yet. And then again, I'm going to do this. I'm going to do a git init. This will initialize a new Git repository. Then inside my Visual Studio Code, I'm going to stage these two files. And then first commit or initial commit, doesn't really matter. And I'm going to do comparison on this. I'm going to take this one. I'm going to mark it as a left folder for comparison. And then I'm going to put it here and mark this as my right folder for comparison. And what I can see is that I do have some objects in here, and I now want to explain what these objects are. When I have staged my files, I have got new objects in here. And these two objects are actually blobs. So what has happened, apart from an index being updated when I said stage something, is that a new blob object has appeared, and this blob object contains the contents of the file that it represents. So in Git, we can easily see the contents of these blob objects simply by using the cat file. So I can do git cat file for print, and then I need to use the hash of that object. The hash of the object is the first two letters from the folders, from the subfolder under objects, and then the rest of it. But you can only use the first several letters. 4 should be enough. So I'm going to use git cat file p8ab6, and then I can see that it's a hello world file. So it shows me that this file, represented by this hash, actually contains these contents. And then I'm going to do the same for the second file. I will do git cat file and then -p and then 09 and then b0. That's the hash of the second object. I'm going to run that, and then I can see that it's hello Mars. There is another command I would like to show. It helps you with manipulating, no, not manipulating, but inspecting the history of Git. So I can do git log. It shows me everything that has been committed so far. And here it tells me that it gives me a fatal error. That's because there are no commits yet on my master branch, and I'm on the master branch right now, and there are no commits. So let me commit this now. So I'm going to do commit, and then I'm going to run this git log, and then it shows me a commit. It shows me that there is this first commit, which has this hash starting with B8. It is authored by me and then gives me the exact date and time when it happened. So what has really happened here? I want to see that. I want to compare my before committing and after committing state of my repository. So we'll refresh, and then let's take a look. First, what I have is index has apparently changed, and it must have changed because I have it, again, as you have seen earlier, I have cleaned up my entire staging area. And something else has happened. I have actually received 2 extra blob objects. So I can open this and open that. And let's take a look. So I have this B8. And if you remember this, my commit starts with B8. So apparently this object in here is a blob, sorry, not a blob object. It's an object which represents a commit. If I do git cat file and then -p and then use these 4 first letters or whatever, I can use an entire hash, or we call it also SHA-1 because it uses SHA-1 algorithm. So I'm going to cat file this commit. What I will receive is this. I see that this is a commit, and I can also see something else. I can see that this commit points to, actually, it contains this tree object, which also has this SHA-1 or hash. And if I take a look at this tree and then do git cat file and then paste this SHA-1, I can see that I have 2 blobs. Each of these blobs represents a file. So again, if you take a look here, this is exactly what I have in my objects subfolder. So my object subfolder is where actually Git stores everything that happens inside Git. So let's take a look at, again, what is a commit. As you have seen, when I committed my staging area into repository, first what happened is that the index area got cleaned. So staging area got cleaned. I have nothing inside my staging area anymore. And then I have received a commit object. And this commit object is not alone. This commit object, and please ignore these SHA hashes. These are just arbitrary in here. I cannot prepare a slide which contains a hash of an object that I will create during the demo. That's physically impossible with Git. That's something that you will come to learn in a future session. So I got a commit which has its own unique hash, and then this commit points to a tree, and this tree also has its own hash. And then I got this tree pointing to 2 different blob objects, and these 2 different blob objects have their own individual hashes. And if you take a look at my screen here, this is exactly what we see here. So first I have shown my commit, then I have shown my tree, and then inside of that tree I've seen that there are 2 files, each of them having their own hash or SHA-1. So this is how this object storage works inside Git. This is how Git actually stores this information. So let's take a look at a little bit more about this. What happens if I want to add something more, like I want to add another file into my Git storage? So what I want to demonstrate right now is that Git storage is actually extremely efficient. So Git is extremely efficient when storing files, when storing changes, and when tracking your changes. I remember once when I've started working with Git, I was helping a customer decide whether they should choose to go with Git or with TFS. And one of the decision points was the size of the storage, because the customer was located in Mauritius, and that's a very remote island in Indian Ocean, and they are very far away from everywhere. Like all data centers have been very far away from them at that time, and for them, every operation with their source control tool or repositories had to be fast. And back then, what I knew about Git is that Git always, like every copy, every machine on Git, every machine that is connected, or actually that clones a remote repository contains the entire repository. So everything that is ever committed in the remote will be also stored in this local clone of that repository. So that part is true. But what I didn't know back then is how efficient Git is at storing that. What I was actually being afraid of choosing Git, because Git would, in my view back then, because I didn't understand how it works on the inside, how it stores data, is that all of those branches, all of those different commits, you would always have to store all of that on every single machine. And there was quite a number of developers on that remote island. And that meant that I was afraid recommending Git, because I was afraid that when all of those people start syncing all of their directories at all times, suddenly they would hit a bottleneck of the internet connection, and it would start becoming slow, like synchronizing, pulling, pushing, everything. That would all cause extra time. But that's not exactly how Git actually works. So what I want to show is how efficient Git is at storing changes. So let's remember, this is where we started from. So this is the state of my repository at this moment. And if you take a look at my screen, this is exactly what you can see here on the left-hand side of my screen. So let's go back into my presentation and let's take a look what will happen if I add another file called file3.txt. So what will happen if I add that file? So let me actually add that file. I'm going to go inside here, and then I'm going to create a new file, file3.txt. And then what I want is I want exactly the same contents as this one. I'm going to save this. So what will happen when I stage this and cool. So what should happen at this point of time? Let's actually take a manual snapshot of this. I'm going to go into my demo folder. I'm going to copy my entire Git folder, and I'm going to remove this one from here, and I'm going to paste this one. And I'm going to, I should have done it before committing. Did I commit? Yes. So I will refresh, and what I have received, this is fine, is I have 2 extra objects. Actually 2 extra subfolders. And when I open this one, I can see one file, and here I can see another file. So what are these files? You might have expected me to receive 3 additional files in there, because we already know that what we get at commit is a commit object. So apparently one of these 2 is or must be a commit object. Then there must be a tree object. And then there should be a new blob, because I have an extra file. So what is really that has happened in here? So if this is what you expect to happen when you add a new file into your repository, then you will be not disappointed, but pleasantly surprised, because Git is, as I said, efficient. What Git will see is that it actually has 2 files that have exactly the same content. And then it will realize I don't need to store this another file, because there is another file already which contains everything exactly the same, except for the file name. But file name is not a property of the blob object. File name is simply a property of a tree object when tree object is created. So let's take a look at that. I'm going to do git log once again. I can see that I have this new log object. I'm going to copy this one, and then I'm going to cat file that, git cat file, sorry, not L but P. And then I can see that I have a different tree. So I can use this tree object, and I can do git cat file, and then this tree object. I can see that I have 3 files in there, but if you pay attention, you will see that here I only have 2 different blobs, because file2 and file3, they contain exactly the same blob content. So there is no need for Git to create a new blob, because it already has that blob. File name is not a part of the blob. Blob is only contents of that file. Good. At this stage, just to make it simpler for you to keep track of my entire remainder of the session, I'm going to reset this once again. So I'm going to go into my, demo folder. I'm going to delete this, and then I'm going to init it again. And by now you already know that I have reset my repository, and I will commit once again, initial commit. And that's where I was demonstrating what was happening without my demo screen. So again, what I have done is I have deleted this folder from here, then back in my, back in here, what I have done is git init, and then this Git folder has appeared, and then I have committed that from Visual Studio Code. Let me just go back once again. My VS Code doesn't see this again for some reason. So I'm going to go in here, then I'm going to do git init, and then initial commit. We'll just try this. Tells me that there is nothing in here, but yeah, something with Visual Studio Code. It did not run all the commands. So I'm going to run git commit again. And then I have exactly this state of the repository. There is one commit object, one tree object, and two blob objects. And if I go in here and do a refresh, I can see that this is what I have. One commit object, one probably commit and tree, and then there are two blobs. The blobs didn't change. The blobs are exactly the same as they used to be. Git didn't need to create new objects. And the reason why I wanted to show this is to show you exactly this screen where you can see that I have two states of repositories, which might easily come from two different machines. As long as a file contains exactly the same contents, that file will have the same SHA or hash on all of the machines in the world. That's how Git works. I will talk more about SHA-1 in one of my next sessions, also in one of my blog posts. And I also go in deep detail about SHA-1 in my Leveraging Git webinar. So if you want to learn more, there will be more to come. But for now, remember that blobs are hashed based on their content, which does not include nothing about that content. It doesn't include anything about the file name, about creation time, access attributes. These are all contained inside of my tree object. So this is what I have at this stage. I have a repository which contains 4 objects. Actually, again, I've done the same. So this was the screen I wanted to show. I have these, which are the same. These are blobs. And apparently I have these, which are different. One of them is a commit, one of them is a tree. As I said, whenever you hash a file on different machine, you will always receive the same cache, regardless of where you created that. And this is what we can see here. So this is my old state of repository. This is my new state of repository. And this is exactly what I can see. I can see that the blobs have not been recreated. Only the timestamp has changed. But commit and tree have been recreated. So this is the situation that we have now obtained in our repository. Let's take a look at the slides. So this is what we have, and this is what I got when I have committed a first commit. So one of the things which people often get wrong about Git is, what does it actually store? Does it store deltas? Because this is what you might get an impression of happening if you simply use visual tools like, for example, Git Lens or maybe other tools like observing pull requests or differences between different commits in, for example, DevOps in Azure or whatever other tool. Git, in fact, does not store deltas. Git stores something completely different. And let's take a look at what is it that Git actually stores. So again, I will start from here. This is the situation that I have. What I have at this stage is one commit, one tree, and then 3 files. So what I want to do right now is I actually want to make sure that I switch to my demo environment before I go on. So what I'm going to do here is I'm going to create a new file. So that file will be called file4.txt. So this is, I will put hello moon in here, and I will save that file. And then, of course, I'm going to commit this, adding file 4. I'm going to first stage this, then commit this. And then let's take a look. So when I refresh the left side view, I see that I have 3 more extra objects. And I can by now know why there should be 3. And we can actually cat file through all that. I can do git log. I can take this here and I will do git cat file. And then I can see that this is the tree object. And if I take a look at here, I can see that the tree object starts with 3, 4, and this is exactly what I have in here. So 3, 4, 7, etc. That's my tree object. And then when I cat file my tree object, so 347c, I can see that I have 4 blobs now. I have file 1, file 2, file 3, and file 4, where file 2 and file 3 again share the blob reference because they have exactly the same content. Whereas file 4 is a new blob object, so it is a B. So it's this one. So these are all of my new objects. This time I have received 3 new objects. So let's take a look at exactly what has happened when I have done a commit. This is what has happened. So I have received a new commit, which has a new tree, and this new tree, yeah, it has this file 4, but it does not have copies of other objects. It simply has this. It has references for exactly the same blobs. Let's take a look at that. Let's take a look at, so remember these 4. I'm now going to do cat file of the first commit, and then cat file of the first tree. And then let's compare this. So this is the second commit, which has these files inside. It has file 1 at 8ab, and it's the same file 1, 8ab. There is no new object. And then 09b, 09b for the next 2 files. And then we only have this extra object. So if we go back to my slide deck, we can see here that this is exactly what has happened. I have new commit, new tree, new extra blob, but this tree points to exact same blobs as the other commit has pointed to. So this is what I have. So what will happen now if I do another commit? What I want to do is I want to actually change my file 3. So yes, you should see my demo. So if I go now to my file 3 and change this hello Mars to hello Jupiter and save this, before I commit, I'm going to take a snapshot, manual one. So I'm going to copy this Git folder, put it in here, then refresh my comparison. It should be exactly the same. So of course, because these are, I don't understand why this is not happening correctly. It has just been copied. So I'm just going to do another comparison. So I'm going to compare this to this. And then I can see that they are exactly the same. And I'm also going to exclude file. I don't want files of the same size to be excluded. So I can see that they are exactly the same. If I take a look at this, this is exactly the same. So what will happen when I commit this extra file? So modifying file3.txt. And then I'm going to stage and commit that file. So what happens in here, when I refresh, I can take a look and I can see again, I've got 3 extra objects. This one, and that one. And why is that? It should be simple to understand, because if we go back to our slide deck and take a look at what has happened here, this has happened. I have commit, new commit pointing to new tree, and this points to all other files, exactly the same blobs as earlier, except to this new file, which points to this new blob that has appeared here. And of course, if I cat file through that, and I will do that, so I'm going to do git log, we can take a look at, okay, we have this 0.3, and that's this one. Apparently, this is the commit object. And if I cat file into that commit object, like this, okay, not like that, but like this, I'm going to do git cat file, and then, sorry, git cat file p. I can see that it has this d6 tree object, and that's this one. So if I do git cat file d622, that's my tree, I can see this now. I can see that file 1 points to the same blob as it used to point. File 2 again points to the same blob as it used to point. File 3, though, points to a different 1165. So let's take a look. 1165, apparently that's a new object that didn't exist earlier. So this is a new object that this new commit has created. So this is how Git has handled this. And yes, I understand that this picture now looks like a royal mess on screen because it's very difficult to track what has happened. But if you take a look at simplified version, this is what we have. We have 3 commit objects, we have 3 tree objects, and we have 4 blob objects. So in total, this is 10 objects. And if you count the objects inside of my folder, I can take a look that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects in my repository. So this is how Git tracks everything. And again, if I take a look at this, this is everything I have in my repository. This is my first commit, this is my second commit, and this is my third commit. So this diagram, these 3 diagrams that you've just seen, explain to you how Git tracks content, or how does it store content. It does not store deltas, it actually stores snapshots of objects. So this is what I have prepared for this time. It has taken a little longer than I expected. I expect to run at about 35 to max 40 minutes, but yeah, I fumbled with these switching screens between demo and slide deck. I'm going to try to not do that mistake in the future. So there will be more. I'm going to blog a little bit about SHA-1. The next session will be about SHA-1, and we will see how SHA-1 works in Git. And I would like to announce this webinar, Leveraging Git. This is my 3rd edition. It has been delivered twice already. I have 2 companies in the queue who have booked this entire webinar for themselves and for their team, and there is a public webinar which still has room for new attendees, which will happen on May 10 to May 12. It starts at 4 p.m. Central European Time, and in that webinar I go not just into inside Git, I go into typical most common Git processes and how they work, and also some advanced Git processes. And this webinar really goes into explaining how Git works on the inside, under the hood, what happens when you do things, what does not happen, like common misconceptions about Git. And it explains and helps you understand how Git works as a tool, makes you a far more of a power user of Git rather than just being a simple user who is sometimes, as I was when I started, afraid of using it. So that's what I have prepared for this time. This is all, and this is now time to actually address questions. So let me switch to my Q&A. So yeah, there are a lot of comments about me not seeing my screen. I really apologize for that. I will try to do that, to pay more attention to that in the future. That's a problem when you're doing live rather than recorded session. I've explained in my first introduction to my live blog why I'm doing live rather than recorded sessions. Okay, don't screen, please share. Yeah, okay. And some greetings. So are there any questions about what you have seen today? I'm going to wait a little longer because typically questions start flowing in a little later. I've noticed myself that when I type something, it takes about a minute for that to reach the chat. So I'm going to ask. Yeah, so I have just sent something to the chat, but let's see when it arrives. Okay, so there is some lag. There are still no questions. So if there are no questions, I'm going to close the session. I'm going to take questions in the comment section, as I always do. Okay, no questions at all. Thank you. Then I'm going to take the questions in the comment section, and I'm going to take the questions in the on the blog. I'm going to blog a little bit more about Git. I really want to make all of users of Git far more at home, far more comfortable with the tool and understanding how the tool actually works on the inside. So this is where my focus will stay for a while in the future. Once again, thanks for attending this new episode of Vieko.live. I'm looking forward to seeing you soon in the next one. Please hit the subscribe button down there. I think it's this side. Also, click the bell icon to be notified when there is no new content on my blog. And I'm looking forward to seeing you in the next iteration, which will come in the next, hopefully next week, but we will see about that. I'm going to do my best. Have a nice afternoon and bye.